Hi, my name is Mr. Kangas, and today we're going to be taking a look at Chapter 7, Section 1, Functions. More specifically in this video though, we're going to be taking a look at a few vocabulary terms. In the next video, we'll actually be taking a look at what functions look like when you graph them, and how you can identify a function when it is graphed. In this video though, we're going to be taking a look at what is a function, what are some of the terms that we're going to see when we're talking about functions, and how we can identify a function when it's in the form of a table, a group of ordered pairs, and eventually we'll also, not in this video, but eventually down the road, we'll also learn how to identify a function when it's in an equation form. But for today, we're going to start with functions and the vocabulary that surrounds them. So the first thing to understand is what a relation is. This is something we've seen before, but just a refresher on what a relation is. And actually, before I start with that, I want to remind you that if at any point you need to pause the video, do it. Because you should be taking notes on this. So when I'm going over a definition, if it makes sense to you, pause the video and write it down, because sometimes I might be moving a little quickly, so I may write something up here and it will only be up here for 5 or 6 seconds, and then at that point you need to pause the video, because 5 or 6 seconds won't be long enough to copy it down or to really take the time to understand it. You might need to pause the video to look at it and write it down. So back to what a relation is. A relation is just simply a group of ordered pair. It's a group of ordered pair. Now, if you're not familiar with what an ordered pair is an X and a Y coordinate that are paired up. Now, with an X and a Y coordinate, you're able to map them on a coordinate grid. So if I had the ordered pair of -2, +3, that means my X coordinate is -2, my Y coordinate is +3. The X coordinate will travel along the X axis, right here. The Y coordinate will travel along the Y axis, right here. So my X coordinate will start at the origin, and it will move -2 spaces, so we move left 1, 2 spaces. My Y coordinate will move me up 3 spaces, because it's a +3. So a +3 moves in the positive direction, and a Y coordinate will only move up or down. Up is the positive direction in this case, so we go up 1, 2, 3. And that is where my ordered pair leads me. That is the point my ordered pair represents on this graph. Now, on an X coordinate, on the X axis, negative numbers move to the left, positive numbers move to the right. Just like on a number line, the negative numbers are on the left, positive are on the right. So a relation is just simply a group of these ordered pair. So if I had more than one, then I would have a relation. So if I have a 2 and a ordered pair 2, 3, remember my X and my Y coordinate relation, might have an ordered pair 5, 7 and an ordered pair of 6, 10. And this would be a relation. Now, a function is a special type of relation, or in other words, a function is a special group of ordered pair. You might want to write that down. A function is a special group of ordered pair. Now, what makes a function so special? That's the big question. What makes one what makes one group of ordered pair stand out from the rest? Well, a function has 2 properties that you're going to be able to see when you're looking at the ordered pair. So if I had a table that had all these ordered pair on it, these groups of ordered pair, let's say I had a 3, a 6, a 4, an 8, 5, 10, 6, 12. So right there, I'm looking at my group of ordered pair, which in this case is a function. Okay, and there are some special elements about a function. Okay, one of which is there's a pattern. Another way you might say is there's a relationship. There's a pattern or there's a relationship between X and Y. Okay, there's a special pattern or relationship between X and Y. In this case, I've actually made the pattern very easy to identify. If you take a look at your X and your Y coordinates, we take a look at X, we take a look at Y. Take a look at X, we take a look at Y. Okay, you can see that when I double X, so I do 3 times 2, I get my Y coordinate. So when I double the X coordinate, 4 times 2 is 8, I get my Y coordinate. So that would be the pattern or relationship in this case. So that's one way you can use to identify a function when you're looking at groups of ordered pairs in a table. Remember, you can also identify functions by looking at these ordered pair when they are graphed. Okay, and we're going to talk about that in the next video. In the next video, we'll actually graph these ordered pairs, and then we'll talk about how you can identify whether or not that group of ordered pairs is a function, just by looking at the dots on the graph. Now, but we're going to, like I said, in this video, we're going to continue talking about just the tables when you're looking at just the table. Now, sometimes the pattern or the relationship between X and Y isn't very obvious. In this case it is. We have actually a very simple pattern. If I were to write this pattern out as an equation, it would be 2x equals y. So in other words, when I multiply the x coordinate times 2, I get the y coordinate, is what that equation is telling me. When I multiply the x coordinate by 2, I get the y coordinate. Okay. Now, in that case, you can see the pattern. Most people would pick up on that pattern or that relationship very quickly. Sometimes, however, you may not be able to look at this table and look at these ordered pair here and see the pattern or relationship very quickly, if at all. Because sometimes the relationship gets really complicated. For example, what if my relationship was this? 47 times the x coordinate plus 3.2 would get me my y coordinate. That is a relationship that could exist, but that's not one I'm going to look at an ordered pair and see. If I look at 3 and 6, for most of us it's very obvious that when I double 3, I get 6. If I showed you the ordered pair, or the function, or the group of ordered pair for this equation, most of us wouldn't be able to tell that there was a relationship between x and y. We would just think they were random numbers. So what's another way that we can identify a function? Another way to identify a function by looking at its table or list of ordered pairs is to check the domain. The x coordinates can only be paired with one y coordinate. Okay, so the x coordinate can only be paired with one y coordinate. So what does that mean? When I look at my x coordinates, if I see another 3 here, if the answer for the y coordinate is not 6, let's say this 3 was paired up with a 7, then that means that this is no longer a function. Because again, a function is supposed to have a pattern. And there's supposed to be a special relationship between x and y. In this case, we said that relationship was that the x coordinate would be doubled, and that's how we would get our y coordinate. So that means every time I see a 3, that 3 gets plugged into my function, it gets multiplied by 2, and I should get an answer of 6. I should never, ever, ever plug 3 into this equation twice and get 2 different answers. That just doesn't make sense. It's not logical. 3 times 2 is always 6. It will never get you another answer. So again, 3 times 2 is always 6. It will never get you another answer. So if you see a repeat in your x-coordinates, and that repeat yields you 2 different answers or gets you 2 different answers. Okay, when I input 3, I got 6. When I input 3, I got 7. I got 2 different answers for the number 3. Okay, when that happens, you do not have a function. So that is the second way to identify a function when you're looking at the table. Okay, you look for a repeat in the domain, and you see if those repeats have different answers. If they do have different answers, you do not have a function. Now, I've used this term a couple times, but I just want to clarify. I'm going to erase this equation up here. This equation, remember, represented my function that I had earlier. But when we're talking about the x and y coordinates of a function, remember, a function is a group of ordered pairs. So another way I could write this is I could actually make them look more like ordered pairs by putting them in their parentheses. Okay. Both of these things represent the same thing. They both represent my function. They both represent a group of ordered pairs. They both represent a list of x coordinates and y coordinates. Some other names you might hear, though, instead of x coordinates, you might hear domain or input. Another name you might hear for the y coordinates, range or output. Now, the most commonly used one, and I'm going to erase this right here. These are 2 ways to identify a function just by looking at its table. And remember, in number 1, this only works sometimes. Sometimes you will see the pattern, sometimes you won't, but there is always a pattern. Number 2 is the most reliable way to identify a function. Okay? Number 1 is less reliable unless you have a simple pattern. So number 2 is the primary way to identify a function. I'm going to erase this now, so if you need to pause the video to write it down, please do so now. Okay. Now back over here, I was just talking about how the x coordinates, when you list them out, sometimes are considered the domain and sometimes are considered the input. The y coordinates are sometimes called the range and sometimes the output. There is no right or wrong term. You don't use one term in one situation and not in another. Technically, you can use them whenever you want. The most common terms, though, and especially ones that will make most sense to us today, given what we're going to be studying in this chapter, will be input and output. Now, why would I call the x's the input and the y's the output? Well, like I said, if I have a function such as this, where 2x equals y, my x-coordinate is being doubled. And my answer that I should get is my y-coordinate. So in other words, when I input 3 into this equation, so I input 3 for x, my output, or my answer, should be y. That's why we might also see this as input and output instead of x and y. So I'm going to input 3, I'm going to output 6. When I input 4, I should output 8. When I input 5, I should output 10. Now, real quick, before I end this video, I want to go over one more thing. When I was talking about the two different ways you can identify a function based on the table only, the first way was to look to see if there's a blatant or obvious pattern or relationship between x and y. Remember, x and y, if you have a function, there will always be a pattern. Always, always, always will be a pattern. Okay? Sometimes you'll be able to see it, and if you can actually see it, then you don't need to waste your time trying to identify whether or not there's a function, because you know there is one. If you see an obvious pattern, then you know there is a function. Now, the second method I gave you to identifying a function was that the domain should never repeat, and that every number in the domain should be matched up with only one number in the range. So, for example, if I see 3 here, and I output 7 over here, then this is no longer a function. Because when I input 3, I got 6. When I input 3 again, I got 7. I got two different answers when I input the same number into the same equation. That doesn't make sense, so that couldn't be a function. What you can see, though, what will happen even if you have a function, okay, this is possible. You might see that I input 2 and -2 into my equation and got the same answer. You can see repeats in the range. That's okay. Repeats in the domain or the input or the x-coordinates, if you see repeats in the left column, not okay. Repeats in the range can be okay. For example, if my pattern or my relationship was that x squared equals y, so in other words, x times itself equals y, well, 2 times itself is 4, and -2 times itself is also 4, because negative times a negative gets you a positive. So it is possible, and it does make sense, that two numbers, such as 2 and -2, would get you the same answer. That does make sense. It doesn't make sense that you would plug the same number into the same equation and get two different answers. So you cannot see repeats in the domain. You can see repeats in the range. So, like I said, the next video we'll be talking more about what functions look like when they are graphed. Okay, so we'll be graphing some functions, and we'll be talking about how you identify a function just by looking at its graph. You don't have to look at any of the ordered pairs, you don't really have to do any math, you just have to look at the graph. So that will be in the next video. Please tune in.